Warning: many pickles were harmed during the making of this video. Do not try this at home.
Yes. Here's our first test of our control pickle experiment.
Ready?
Yeah.
It's cooking.
Oh! It works! Oh! It works! Shut it off, shut it off! Yeah! Oh my god! For the materials for this project, we used 1 wire, 2 screws, plank of wood, and we had a pickle. So the setup was, we opened up our wire and we used the multimeter to determine the hot and the neutral wires. We drilled the screws into the piece of wood and we put that piece of wood on top of the plate. We then wrapped the copper wires around the screws, 1 wire per screw. After that, we plugged the extension cord into the wall, making sure that the extension cord was turned off. After that, we turned on the extension cord and here's what happened.
It's working. Listen, now I hear it.
Oh my god.
So yeah, after that insane result, naturally we had to go for the double.
I think it's going through.
So what causes the pickle to light up? Well, when electricity passes through the pickle, it's conducted through the Na+ and Cl- ions that are in the pickle. The electricity excites the electron to a higher energy state, and when it drops back down to ground state, this energy is emitted in forms of sound, heat, and most importantly, light. This is why we can hear the electricity, see smoke rising off the pickle, and we could see light coming out of it. For fun, we also tried it on a hot dog because we had to. But anyway, we also had one more question. What happens if we plug an LED into the pickle? The result was kind of funny.
That one's gone! Wait, okay, ready? No! Oh, they're all gone.
And after that, we were just asking ourselves, why is this working? These LEDs are supposed to be running off of, what, 3 to 5 volts DC? This was running off of 120 volts AC coming straight from my wall. If I shoved one of these LEDs in the wall, it would blow up and I'd probably have a bunch of sparks in my face. So why is it working when I plug it into a pickle? So we took out the multimeter and set it up to take some measurements. This first one here is just showing how many volts were going through the circuit. Around 120 volts AC, the same amount of power that comes out of an outlet from a wall. After putting a bunch of LEDs in pickles, we noticed a common trend. Once the pickle would start lighting up, the LED would shut off.
Yo, wait. Oh, it's hot. Oh no, that's touching the copper. Okay. Oh. So it works until it goes.
Wait.
Oh wait, is there no electricity passing through after? That's pretty cool.
Now, we conducted multiple tests, and it seemed that this idea was true. When the pickle was lighting up, the lights would shut off. And when the pickle wasn't lighting up but electricity was still passing through it, the lights would turn on. But turns out we had a weird case, where it was actually the opposite.
Why is it turning on now? It's supposed to shut off.
We decided to take some voltage readings in the pickle. After sticking the multimeter probes inside, we can see that before the pickle lights up, there's a much higher voltage than when the pickle is actually lighting up. So then we probed our LED, and the voltage readings we saw answered all of our questions. We saw that when the LEDs were lit up, they were getting a reading of around 2.5 to 5 volts, which makes perfect sense because, as I said before, they're designed for about 3 to 5 volts. LEDs weren't turned on, they were getting a voltage reading of 1.5 to 0.7, making so much sense because they don't have enough electricity to turn on. So after many tests, here's our hypothesis. When electricity initially travels through the pickle, it is searching for the least resistant path to ground. So it's flowing throughout the pickle during the beginning phase. The LED receives enough electricity during this phase to turn on. Then, when the least resistant path is found, the circuit completes, causing most of the electricity to flow on that one path. So at this point, the LED doesn't receive enough electricity, so it won't turn on. This also explains why the pickle glows orange now and not before. There's so much electricity going through one path at that point. This is our, quote, normal case. If the LED is close enough to that path, it could still receive enough electricity to turn on. And if the LED is connected to that path, it fries as it receives close to 120 volts of electricity. Way too much for it to handle. And thank you all for watching. Also, I had to try the pickle. I mean, it was disgusting, but...
Alright, so you're gonna taste the fried pickle now.
Ooh, it's still warm. Oh, look, it's burnt.
Nice and char. How does it taste? Too late.
That was good.
Where did I put that paper towel?
Do not the fake hot dogs.
Oh, it smells like
It's like lingering.
Oh, it smells like the burnt leather.
Mmm.
It smells like the burnt leather.
You're right. Oh, yes.
What smoke rings? Did you see those? Whoa, come here, it's cooking it. Whoa, look at it cook.
I saw it spark.
Whoa.
I said we'd leave this one on for a while.
Okay.
It's sparking on down here.
Yeah, because all the juice, the instant it gets cooked, the juices are falling onto it. Oh, the guy is enraged.